Hello everyone. In this video, we'll go over some examples where we learn to compute probabilities for standard normal distributions. So let's begin. Suppose we're told that Z is a random variable which follows a standard normal distribution. That is, it has a mean of 0 and a standard deviation of 1. Let's find the probability of Z being between 0 and 2.25. Now, just like how we solved the previous cases, just like how we did P of 3 less than x less than 9 as P of x less than 9 minus P of x less than 3, we do something similar here. So this is just going to be P of Z lesser than or equal to 2.25 minus P of Z lesser than or equal to 0. And this will give us the area between the points 0 and 2.25. So we're going to do P norm 2.25 mean 0 is 1 minus P norm 0, 0, 1. And we get the answer 0.487775. That's the answer to the first question. Let's look at the second one. Now, this is very similar to the first one, but it's on the other side of the mean. We want to find the area between minus 2.25 and 0. Now, let's actually compute this in the same way, but then I'll show you an image which helps us visualize how this answer will actually look like. So let's see, give me a second. Now, I'm going to tell you that the answer to this question is going to be the same as the answer we saw for the previous question. So let's check if that is indeed the case. Okay, so then we have this minus 2.25, 0 and 1. And there we go. The answers are the same. And why is this so? Well, let me show you a different screen and help you understand what's happening, help you understand and see what's going on. Now, if we take our normal distribution, the standard normal distribution as a bell curve, we have the mean here and it's a symmetric distribution. Now, every value here along the axis, the z-score will tell us how many standard deviations we are away from this mean, and the mean is 0. So you could directly interpret the z-score as how many standard deviations away a particular value is. So a z-score of 2.25 would mean I'm 2.25 standard deviations above the mean. Minus 2.25 would be the same distance but below the mean. Now, the first question where we found 0 less than z less than 2.25 was this area in yellow between 0 and 2.25. And we saw that that area was about 0.487. The second question was the area from minus 2.25 to 0, which is the area in orange. And that was also the same number. Now, once you visualize it and you see what exactly the different areas that we actually computed, they are actually mirrored images, right? Given the symmetry of the normal distribution, this region in yellow should have the same region as this, this orange colored region, because both of them are equidistant. The endpoints are equidistant from the mean, and that is why we can use symmetry very easily and say that these two areas are the same. So once you visualize a normal distribution and put down things this way, a lot of these calculations will become a lot easier. So let's see a few more examples. So I'm going to go back to my R file. Okay. Now, let's find the third one. So this is the area between minus 2.5 and 1.5. So following the standard practice, I'm just going to do this. Minus P norm, minus 2.5, 0, 1. And the answer is 0.9269. Okay. So far, so good. Now, the next one. We want to find the value z1 such that the area to the right of this curve is 0.6. Or actually, we'll come to that question in a bit. Or maybe not. Let's actually deal with this question for now. No, in hindsight, let me do E and then come back to D. So find Z1 such that the area to the left of this point is 0.6. Now this is something we are very familiar with. All that we have to do is use the inverse function and we can directly use the Q norm function. So Q norm, the area to the left of the particular point I'm interested in is 0.6 and the mean is 0, standard deviation is 1 for the normal distribution. So which point is this? Turns out this particular point is 0.2533. Now, keep this in mind, and then we'll now revisit question number D. Question number D is the opposite of question E. We want to find the point Z1 such that the area to the right of this point is 0.6. Now let's visualize this for just a second. Now, this particular chart, the label that you're seeing here, okay, the orange shaded region, this is where P of Z being lesser than or equal to Z1 is 0.6, right? And this is exactly what we found out, and the answer is 0.2533. In Excel, you would have used the norm.inf command. In R, we use the qnorm command. Qnorm 0.6, 0, and 1. Now, the next question says that we want to find Z1 such that the area to the right of this point is 0.6. So Z greater than or equal to Z1 is 0.6. Now, the qnorm function in R, the first argument that you feed in there is actually going to be the area to the left of the particular point that we are trying to find out. So that's where we just have to be a little bit careful. And so when Z1 is defined in this way, when we are given the area to the right of a particular point, in order to be able to use the functions that R has given us, what we do is we find the area to the left of that point. And how do we do that? We know that the entire area is equal to 1. So 1 minus area to the right will give me area to the left. So I find out that area to the left of Z1 will be 0.4. So if I'm given a Z1 such that area to the right is 0.6, then I know that the area to the left of that point has to be 0.4. And I'll take this information in and I'll go ahead and put it into my Q norm and find 0.4, 0, and 1. And let's see what that answer is. So let me go back to my R. So here, so this is actually nothing but P of Z being lesser than or equal to Z1 is equal to 0.4. So now I'll use the Q norm function. Q norm 0.401, and the answer is right there. The answer is now minus 0.2533. Remember, the answer to the previous question was plus 0.2533. So we're getting two numbers that are essentially the same distance away from the mean of 0, but on either directions. So how does this look visually? So if you notice, minus 0.2533 is a point where 40% of the area is to the left of it. And by symmetry, we can say that the same coordinate, if I measure 0.2533 here, the area on the other side to the right of that point has to be 0.4. Right? So if the area to the left of 0.2533 is minus 0.2533 is 40%, and if I take an equidistant measure here of Z1, the area to the right of that point should be the same as this region here, meaning the area to the right of that point has to be 0.4, which we saw in the previous case when we solved for the earlier problem. When we measured Z1 such that 60% of it was below, naturally 40% of it was above. So, and now when you're able to visualize this, you can clearly see how, because of the symmetry of normal distributions, you're able to get these, similar magnitudes, numbers which have similar magnitudes but have different signs. And this is going to come in very handy when we're going to solve the next problem. So let me go back to our studio screen. Now, we want to find Z1 such that the area under the curve from minus Z1 to plus Z1 is equal to 0.9. So let's visualize this. Okay, now let me go to my notepad. Now we're told that we have a normal distribution. Okay, and we have a mean of 0. Okay, and we're told that this area from minus Z1 to plus Z1, this entire area is equal to 0.9. Okay, is equal to 0.9. And we are asked to find Z1. Now, based on the symmetry, we know that if this is Z1 units below, and we know that this is Z1 units above, okay? And because they are equidistant away from the mean, the area that is enclosed from this point to 0 will be the same as the area that is enclosed from this point to 0. So essentially, the 90% of the area which is in this shaded region is split equally on either sides of the mean. So we have this area equal to 0.45 and this particular area equal to 0.45. Once you split it off that way, you know that this area to the left of minus Z1 is going to be 0.5 minus 0.45, which is equal to 0.05. So the area to the left of minus Z1 will be just 0.05. Similarly, the area to the right of Z1 will be 0.05. And that way, you know, 0.45 plus 0.05 is equal to half on, you know, half of the area to the right of the mean. And then we have half of the area to the left of the mean. Now, once you decode and unpack this problem this way, if we want to find Z1 such that probability of minus Z1 less than Z1 is equal to 0.9, we can actually find Z1 such that the probability of Z being lesser than or equal to minus Z1 is equal to 0.05. Or we could also do probability of Z being greater than or equal to Z1 is 0.05. Essentially, I'm just describing this area and this area. Now, this is preferable because we easily have the Q norm function. So I could just put this into Q norm and find the value such that area to the left of that point is equal to 0.05 for a standard normal distribution. And that is all I have to do to answer this particular question. So going back to my RStudio, this is actually nothing but P of Z being lesser than or equal to minus Z1 is equal to 0.05. Now, the thing to note here is that it's going to give us the point which is minus Z1. Okay, we have to actually find the value of just Z1. So one way to do that is let's find out Z1 for that matter. So let's get Q norm 0.05, 0 and 1. So we get the point minus 1.644. Now minus 1.644 just tells us that this point is to the left of the mean. The actual Z1 value is just 1.644. So to get that, all I have to do is just multiply this number by minus 1. And when I do it that way, I get 1.644. So if I go back to my drawing, minus Z1 is going to be minus 1.644. This point is going to be plus 1.644. And that's how we solve this question. So that's some examples with standard normal distribution. I have a couple more problems here for you to work through. What I'll do is, in fact, some of the questions just require you to think and apply yourselves a little bit. So see, for instance, what's the z-score for a patient? This doesn't require any specific formulas that we've actually been reviewing in this video, but it just needs you to run some basic calculations. So anyway, so take a look at the remaining examples and work through them. And I'll also provide answers to all of these in the R script. And practice with some of these and try them out. Happy learning.